Hello and welcome to this introductory lesson about the activity class in Android. In this lesson, we will cover aspects and usage of the activity class in our applications. As per the documentation on developer.android.com, an activity is an application component that provides a screen with which users can interact in order to do something, such as dial the phone, take a photo, send an email, or view a map. Each activity is given a window in which to draw its user interface. The window typically fills the screen, but may be smaller than the screen and flow on top of other windows. With the release of Android 3.0 Honeycomb, activities gained a new definition as a host for the fragment components, which we will cover more in a future lesson. In many cases, each screen of an application will constitute a separate activity, although this is by no means necessary, and other implementations are also available. Now let's take a look at an example flow through several activities. When a user clicks an icon for an application, the Android system notifies that application to open its main launcher activity. The main launcher activity is defined via intent filter in the Android manifest, which we will cover soon. In our previous examples, the main launcher activity was commonly called main activity, and the code for that activity was saved in mainActivity.java, which normally initialized the UI from layout activity main XML. Once the main launch activity has been opened, the user might want more information about some of the content displayed. In many cases, this will require opening a new activity to display the extended content, as we see here in this diagram. Once in the new activity with extended content, the user may want to return to the previous screen. As part of the Android operating system, the back button can be utilized to return to a previous activity in the application. If the back button is pressed on the last activity opened from a specific application, the home screen or another application will be shown. The activity class is a complex component offering a wide array of features and configurable attributes. As we have previously seen, the UI for an activity can easily be set, most commonly in the onCreate method, by calling the method setContentView. In addition to onCreate, activities have several lifecycle callbacks, like onPause, onStart, and onDestroy, that can be overridden to implement code tied to those aspects of the activity lifecycle. A very important procedure when implementing a new activity within an application is that all activities started in the application must be declared within the manifest. If an activity is started in an application that has not been declared in the Android manifest, then it will cause the application to crash. Part of the capabilities of the activity class is that they can be started for a result. This means that an activity can be started and the user can complete some action in that activity, and then return to the previous activity with the result. Activities can also be declared to receive callbacks for configuration changes like orientation changes. By default, the Android framework will handle configuration changes accordingly by initializing the appropriate resource and assets per the device configuration. Since one application can have many activities, each representing their own logic, UI, and configurations for a specific screen in the application, the activity system allows for easy transfer of information when starting a new activity, so I can receive pertinent information from its initialization from a previous activity. In this part of the lesson, we'll cover the activity lifecycle in Android. As we previously covered in the introduction to activities, a single application can consist of several activities flowing from one to the next. In the transition between these activity screens, the activities will go through their own regulated lifecycle. This image from the activity reference resource on developer.android.com shows the different states of the activity lifecycle. In this diagram, the rectangular gray nodes denote lifecycle callbacks. These callbacks can be overridden in your custom activities so that your activity can operate accordingly during these lifecycle stages. The colored ovals in this diagram represent the major stages of the activity lifecycle, like when an activity is launched or shut down. Let's take a look at each of the stages and callbacks in this diagram. First, the application is launched by the user or another system action. Then the onCreate callback is called. OnCreate is called when the activity is first created. This is where you should do all of your normal static setup, like create views, bind data to lists, and so on. This method is passed a bundle object containing the activity's previous state if that state was captured. We then pass to the onStart callback. The onStart callback is called just before the activity becomes visible to the user, followed by onResume if the activity comes to the foreground, or onStop if it becomes hidden. OnResume is called just before the activity starts interacting with the user. At this point, the activity is at the top of the activity stack, with user input going to it. Now the activity is running, and in the foreground for the user to interact with. Then a user could navigate to a new activity, press the back button to return to a previous activity, or another operation to navigate away from this current activity. That is when the onPause callback is called. OnPause is called when the system is about to start resuming another activity. This method is typically used to commit unsafe changes to persistent data, stop animations and other things that may be consuming CPU time, and so on. It should do whatever it does very quickly because the next activity will not be resumed until it returns. The onStop callback is called when the activity is no longer visible to the user. This may happen because it is being destroyed or because another activity has been resumed and is covering it. The onDestroy callback is called before the activity is destroyed. This is the final call the activity will receive. It could be called either because the activity is finishing or because the system is temporarily destroying this instance of the activity just to save space. You can distinguish between these two scenarios with the method isFinishing. You'll notice that there are several loops in the activity lifecycle. For instance, the activity can go from the onPause state back to the onResume state in the case an activity is temporarily hidden and now needs to be shown again. Or in the case an activity has been stopped and now needs to be restarted, we arrive from the onStop callback to the onRestart callback. When designing the activities for your application, it may be important to implement these callbacks in your activities. They can provide important information, like when we receive the onCreate callback, it is time to prepare the UI for our activity. Also in the case of threading operations, animations, and other operations that should only be done when the activity is running, we can utilize the callbacks to track when the activity has been started or when it has been stopped. Sometimes it is important to track when a user has stopped looking at an activity. Maybe, for instance, the activity contains some text, and we want to save the last scroll position that the user saw of the text. In the onPause callback, we can easily save this information of when the activity is possibly being dismissed or hidden, so that we can restore that state the next time the activity is shown. It is extremely important to realize that activity callbacks run on the UI thread, so they should contain short and quick operations. Longer operations should be posted to another thread. Performing long operations or other performance hangups can cause your UI to become slow and sluggish and unresponsive. In some cases, this may cause an ANR, or application not responding dialog, pictured here. Generally, the Android system displays an ANR if an application cannot respond to user input, for instance no response to an input event, like a key press or touch event, within 5 seconds, or if a broadcast receiver has not finished executing within 10 seconds. Now that we have seen what happens in the activity lifecycle, and in particular the callbacks to this lifecycle, let's take a closer look at seeing the actions that take place when switching between activities. In this part of the lesson, we'll take a closer look at what happens when we switch between activities in the same application and between activities from separate applications. We previously mentioned that activity can be paused or stopped to start another activity. Let's take an example of two separate applications, Application A and Application B. Application A has two activities, Activity A and Activity B. Activity A of Application A is the main launch activity for the application. So when a user opens the application, it will launch to Activity A as seen here in this flow diagram. In Activity A, there's an option to see more information about an item. When the user clicks the option, Activity B is open and shows more detailed information about that item. In Activity B, there is another option to send that detailed information via a third-party application. When the user clicks the Send button, we open a second application, Application B, with its main launch activity of Activity A. This is a simple flow of how we move from one activity to another. In a later lesson, we'll cover more in depth the activity backstack and tasks in Android. Now let's take a closer look at what happens when we switch between two activities. When the user clicks the More Info button and we move from Activity A to activity B of application A, we followed a specific flow that can be tracked via the activity's life cycles. First, activity A's on pause was called, notifying us that it would soon be dismissed from the foreground. Then activity B's on create, on start, and on resume would be called to prepare it for being displayed in the foreground. After that, activity B would have the user's focus, and activity A would no longer be visible. Finally, activity A's on stop would be called. Thank you for joining us in this lesson on switching activities. Join us in the next video where we will cover the lab exercise for this section.